Hi there, I'm Michele. I'm a licensed massage therapist from Washington, and I bring you MBLEx resources both here on YouTube and on my website. I have a great list of resources for you for tackling that massage and bodywork licensing exam with calm and confidence. I have ebooks, practice tests, study guides, and courses for those of you who want to take a deeper dive. But today we're going to be talking about the digestive system. It's the 28th video in my anatomy and physiology series. I'm creating all of these courses, creating all these videos to create a huge, mega anatomy and physiology course for those of you who have been out of the loop for a while or need somebody else to teach it to you, just what you need to know in order to pass the licensing exam. So I want to get these videos out to you sooner than the course is actually ready, so I'm posting them on YouTube ahead of time. In this video, I'm going to be talking about digestive system functions, the enteric nervous system and how it works, the gastrointestinal tract layer anatomy, the organs of the digestive system. Then I'm going to talk about metabolism and nutrients, and at the very end, we're going to go over some practice test questions that you might be seeing on the MBLEx. So before we get into it, I do want to remind you that I'm not going to be talking about pathology specifically because I've already created videos for that, a video specifically for digestive system pathologies. It's going to be linked in the description and pinned in the comments. And also I have an entire course that has to do with all the pathologies for all the body systems that's available on my website. It's linked in the description and in the pinned video. Make sure and subscribe so that you can be in the loop for all the videos that I'm creating to put you in the right place for passing that massage and bodywork licensing exam. And also make sure and like the video so that other future massage therapists and bodyworkers can have this information to help them to be able to also get in there to be massage therapists. We want to give them as much support as possible, and giving it a like helps the algorithm. Anyway, without any further ado, let's go ahead and get into the slideshow. Your body's fuel system. The digestive system is the body's gateway for turning food into usable energy, nutrients, and warmth. Functions essential for every cell, organ, and body system. It breaks down food, absorbs what the body needs, and eliminates what it doesn't, while also hosting a powerful second brain, the enteric nervous system, which influences emotion, immunity, and overall well-being. For massage therapists and body workers, understanding the digestive system is vital for recognizing when massage should be modified or avoided, supporting clients with tension patterns related to visceral organs, and appreciating how stress reduction, breathing, and parasympathetic activation can improve digestive function. So the functions of the digestive system, there's all of this huge list that I found in the textbooks that I was working on. But what it really comes down to is it digests food to provide nutrients for cellular metabolism. It eliminates solid waste from the body. That means food in, poop out, and assists in regulating the body temperature by generating heat as a byproduct of metabolism. We're going to talk about metabolism a little bit more in detail as we go on with the slideshow. What is the enteric nervous system? It is the brain of the gut. That is, that it has its own self-sustaining functions, that it doesn't need any part of the brain, the actual nervous system. It has its own nervous system. There's a network of 20 to 600 million neurons in the gastrointestinal tract. That's gastrointestinal means like all the stuff where your food goes in and the other stuff goes out. That's the entire thing. So it's capable of functioning independently from the central nervous system, but it does communicate with the brain. So it does tell the brain that things are going on, but it doesn't need the brain to continue functioning. So that's how the digestive system can keep working even if there are problems with the central nervous system connecting with it. So the enteric nervous system will regulate motility. We have a definition for motility back here. Motility, movement of materials through the GI tract. Okay.
and enzyme secretion, blood flow, and reflexes along the GI tract. So it doesn't have to connect with the spinal cord for reflexes to happen. It has its own sensory neurons detecting stretch, chemical contents, irritation, and hormones. Maybe if I switched mouses, I'd quit flipping back and forth. Whoop! Now I'm really messing up. And then the enteric nervous system plays a major role in the gut-brain communication. If you're having emotional responses to something that's going on in your life, it can affect your digestion. And also the autonomic nervous system has stuff to do with that too. But yeah, it will. The enteric nervous system affects your appetite and your anxiety and your stress regulation. If you're doing really well in your gut, it really helps to handle life's emotional ups and downs. Interesting fact, not something for the MBLEx though, so don't worry about it. Components of the gastrointestinal tract. We have the actual GI tract with all the stuff, and then we have some accessory organs that help with digestion. So let's go through the tube, the donut, from the beginning to the end. We've got the mouth, that's where the food goes in. Pharynx, the food slides down. Esophagus, food's going down. Stomach is starting to get churned. Small intestine gets churned and nutrients get pulled out. And then large intestine is basically where the water gets pulled out and all the stuff gets turned into the brown stuff. And then we have the accessory organs, which are the teeth and the tongue, the salivary glands, and that's for, both of these are for pre-digestion before the food goes down into the stomach. Then we have the liver and gallbladder, which produce bile, which help with digestion, and also the pancreas has its own stuff that it produces that helps with digestion and protecting the small intestine from damage from hydrochloric acid. The actual mucosal lining and all of the anatomy of the gastrointestinal tract is mostly the same all the way down the esophagus and beyond. There's a couple little changes that happen in the stomach, but most of the GI tract is made like this. We've got the first layer on the inside, which is the mucosa. It does have epithelial cells, which creates a mucus or secretes other stuff too. So enzymes and mucus, and it also absorbs and protects the rest of the cells of the GI tract from any kind of trouble. The mucosal layer of the GI tract contains chemoreceptors and stretch receptors for those enteric nervous system reflexes. So it can tell when you're eating something that's not right for you, and that will help you to be able to get it out faster through vomiting or through diarrhea. Or it has stretch receptors for when you've eaten enough. And also the mucosal layer is where those Peyer's patches we were talking about in the lymphatic system, that's where they live. Those little green dots embedded in the mucosal layer. Then we have the submucosa, which is the next layer up in there. So that's it's pointing at this squiggle that's coming out, but I would say, muscularis is this part. So the submucosa would be the red ring around the outside. And that is the areolar connective tissue with lymph vessels and blood vessels and glands for regulating the secretions, and it supplies nutrients to the mucosal part and supports with the absorption of nutrients that are going to be going into those blood vessels. And then the muscularis is where the smooth muscle layer is that squeezes the GI tract to create peristalsis. And segmentation, segmentation is another version of peristalsis. So peristalsis is where the muscle contracts, the muscle of the GI tract contracts, and it squeezes the food, or chyme is another word for it. It squeezes it down the tube to go on to the next section. But there's also segmentation, where there are different muscles that will be contracting back and forth, which mixes everything up and helps to aid in further digestion, especially with enzymes. It contains the myoenteric plexus, which controls that motility. So the enteric plexus is a bunch of nerves that tell the muscles to squeeze. And there is skeletal muscle, though. It's smooth muscle through most of the GI tract, but in the mouth, the pharynx, and the anus, we have skeletal muscle. The fourth layer is the serosa, which is this light-colored area. The serosa is also the visceral peritoneum. It's the peritoneum is the name for the membrane that lives out all around and protects the digestive system. We're going to talk a little bit more about the peritoneum, but it's the outermost membrane of the digestive system. But it reduces friction of the digestive system with all of the other organs of the body, with the skin, with the vertebrae. It really helps to protect everything. We have different chunks of peritoneum, and I'm going to go through and show you all of that. I believe it was unit 5 that we talk about membranes. The peritoneum and all the visceral membranes are basically like protective bubbles. They're bubble wrap for our organs. The innermost layer that's attached to the organ is always called the visceral layer, and the outside layer is always called the parietal layer, and then in the middle of it there's going to be liquid. So it's a liquid bubble that will protect your visceral organs. So in this case, those would be our digestive organs. So I'm going to wait for this thing to slide around. Let's see. Am I going to turn it around? Here we go. So that's the parietal layer that protects our organs from any kind of friction or damage. And then the mesentery, I have picked images for the mesentery and the greater omentum, which are other parts of that peritoneum. So the mesentery is a special membrane that protects the small intestine. The greater omentum is like a sleeve of fatty tissue that protects the whole small and large intestine. The lesser omentum attaches the stomach to the liver. So it keeps all that in place where it should be. So basically the point of all these membrane pockets is to keep our organs where they're supposed to be and to keep them safe. So let's go ahead and start talking about all the organs that are specific to the digestive system. We're going to start with the mouth and the pharynx. We talked about the pharynx a little bit in the respiratory system. It's the tube that takes the food down to where it needs to go. Mastication is the mechanical process of chewing your food in your mouth. Different parts of the mouth that we have the hard palate and we have the soft palate. The hard palate is the hard part at the roof of our mouth, and then the soft palate is going to be like a soft flap that keeps the food from going up into the nasal passageway. It just kind of propels the food downward. Then we have the tongue, which is a muscle that pushes the food backward, and we have the teeth. And then we have the salivary glands, boop, boop, boop. Those are the glands that create enzymes for us to start breaking down our food when we're chewing it. So different salivary glands that you don't have to memorize for the MBLEx, it's not necessary. But knowing their salivary glands is important. A bolus is your chewed up food. And then it becomes chyme after it gets stirred around in the stomach. But first is bolus. It's the food that's mixed with saliva for swallowing. That's something to share at a party when you need a little bit of useless information. And then, of course, the pharynx directs the food, and it's got a swallow reflex, which is that epiglottis that flaps over and protects the trachea from getting food down inside of it. So the esophagus is where peristalsis is going to start. So there's the bolus, the food blob, and it's getting pulled down the esophagus thanks to smooth muscle that squeezes the food all the way down the tube. We have 2 sphincters. At the top, we have the esophageal sphincter, and that's going to be right below the epiglottis. That helps to keep the food from going up into our throat, or to keep the hydrochloric acid from the stomach from going up into our throat. And then at the base of the esophagus is the lower esophageal, or also known as cardiac sphincter, which it really helps protect the acid from going up into the esophagus. No digestion occurs here. It's just moving the food down into the further churning area, just past the lungs and the heart where it needs to go. In the stomach, we have 3 different parts of the stomach. We have the top part, which is called the fundus. We have the main body part, and then where it comes down, it looks like a paisley here, little tear shape. The pointy part of the shape is called the pylorus, and that's where it attaches to the small intestine. The food goes out. So esophagus comes down, attaches to the fundus, and then there's the body. What does it do? It digests food in 2 different ways. We have mechanical digestion, which is the mixing and the churning. And then we have chemical digestion, which is hydrochloric acid and pepsin or pepsinogen, which are enzymes that help to digest our foods. So that's where the first churning happens. There is an additional layer of muscle in addition to I think I talked about it. Boop, 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 boop. In the muscle, circular and longitudinal muscles in the muscularis. So there's 2 different directions. So we have like longitudinal and we have round going around. So lengthwise and round muscles. But in the stomach, there's a 3rd kind of muscle. I think it's oblique, what they call it, the oblique muscle layer. So we have 3 different kinds of muscles which help to churn that food and to break it down. And then the semi-liquid food that is produced by the stomach and goes down into the small intestine is called the chyme or chyme. I think it's called chyme. Anyway, so it's this sphincter down here. We remember this is the cardiac sphincter where the esophagus attaches to the stomach, but the sphincter at the base of the stomach attaching to the duodenum would be the pyloric sphincter. Pylorus being the point, and where it goes out, it would be the pyloric sphincter. Now we're moving into the small intestine. I had this image of the intestines, and it did not have the duodenum. So I just went ahead and drew it on there for you guys. And so just imagine this is where the stomach is. So the duodenum is a small, short part. The jejunum is the majority of the upper part. And then the segment toward the end is called the ileum. There's no real landmark that divides them. Just know that there's 3 different parts. That's really all you need to know for the MBLEx, is that there's these 3 different parts of the small intestine. The inside the small intestine, that's where we have the primary site of digestion and absorption of our nutrients. So most of the nutrients we get are in the small intestine. That's why it's so important to keep our small intestine healthy, because that's where we're getting our nutrients to keep our body working right. The way that the nutrients are absorbed is because we have these structures inside the lining of that mucosal membrane that I was talking about. Plica are little sticky outies that have villi with capillaries and lacteals all over them. So imagine on the inside there's all these little sticky outies inside of it. Do I have an image of it? No, I don't. There are all these little sticky outies inside of here that have little tiny brushes and villi all over them. And it exponentially increases the surface area of the small intestine so that there's a higher chance of nutrient absorption. So that's an important thing to know. Just nutrient absorption happens because of the increased surface area thanks to these structures. But there's not a lot that you need to know about that. They're about somewhere close to the top of the small intestine. We've got the place where the pancreas will secrete enzymes to protect it. They neutralize the hydrochloric acid to protect the duodenum from the hydrochloric acid. And then we also have a place in here too where the liver has a duct that secretes bile. which helps with that chemical digestion in the small intestine. Once again, we have peristalsis, but then in the small intestine, we have the addition of mechanical process called segmentation, where the food gets churned in several different directions so that it mixes together. And then the peristalsis pushes it forward, down toward the large intestine. Large intestine, it houses that beneficial gut bacteria that helps to get the last of those nutrients out, specifically vitamins, and it stores the feces and compacts it for eventually eliminating it by absorbing the water out of that large intestine. Appendix is this little sticky outie right here. It has its own lymph structures inside of it, and there's going to be a lot of bacteria that live in there because it's filtering out the lymph that's in the area. And if something happens to it by becoming ruptured, then it can cause huge problems. So that's why that's really important. The colon or the large intestine will also absorb electrolytes, vitamin K and B vitamins, thanks to that bacterial production. That's where the bacteria are. We need those B vitamins. So here are the different structures of the large intestine. First of all, this is where the direction that the brown stuff goes. Okay. Small intestine goes into the ascending colon. Ascending means going up. Colon going up. There's a big turn. It's called the hepatic fixture because the liver is right here, and HEPA is another name for liver or filtering. We have the transverse colon. I put an arrow right over the top of that. Okay, so I fixed that. So you can see it says hepatic fixture where the liver is, to transverse colon, to splenic fixture, which is the next turn. It's close to the spleen. That's why they call it the splenic fixture. And then it's the descending colon, which is the last area where everything gets stored before it takes another turn at the sigmoid colon. And then the rectum is the last little section. And there's the anus where everything comes out. You might need to know some of these for the MBLEx. All right, so accessory digestive organs that you'll need to know for the MBLEx. The liver, very important. Hepatocytes produce bile to emulsify the fats. And then bile is then stored in the gallbladder. So the fat emulsification does not happen in the liver. It's just producing the bile, and also it filters out the blood. It filters out dead blood cells, and it will store glucose as well. It also filters out, in addition to blood cells, it also filters out any kind of medications. It filters hormones and then this other chemical called bilirubin. It creates the bile and then it stores it in this other structure called the gallbladder. So there's like a pocket of bile in that gallbladder, and that helps you to be able to digest fats. So keep that gallbladder healthy so you can keep your fat digestion in order. So they call it the common bile duct, is where their bile goes from the liver to the gallbladder, and then from the gallbladder into the digestive system. Pancreas is another accessory organ. We know that it creates our insulin for the endocrine system, but also it creates a juice that goes into that duct. And that duct has bicarbonate and other digestive enzymes such as amylase, lipase, and trypsin for all these different nutrients absorption. It neutralizes acidic chyme before entering the duodenum. I don't know how it's said. Essential for final chemical digestion. Moving on to metabolism. Metabolism is all the chemical reactions in the body. So anytime that the cell is doing anything using ATP, it's called metabolism. Anabolism is where a molecule becomes built and it uses energy to build it. Catabolism is where a nutrient gets broken down, or something is broken down so that the body can use it, and ATP comes off of it so that we can use that. So that's how metabolism works. It's either building molecules or it's taking molecules apart. When we build molecules, we use ATP. When we take them apart, we get ATP. I explain this more thoroughly in my slideshow about cells. So go check that out. I believe it's Unit 3. Nutrients are divided into macronutrients and micronutrients. So we're going to talk about all that in the next few slides. But real quick, for our appetite and hunger, that's going to be regulated by the hypothalamus, which is influenced by chemoreceptors, telling us whether or not we're missing nutrients. It's regulated by our emotions and our habits and our environment and our stress. So all of these things can affect our appetite. So that's good to know when it comes to metabolism. Your basal metabolic rate, something that you need to know for the MBLEx. Basal metabolic rate is the amount of energy that you need when you're resting. Okay, so when you're not doing anything else, how many calories are you burning? So the digestive and metabolic efficiency varies by individual. So like I'm a middle-aged woman, my basal metabolic rate is much slower than a 20-year-old man. Oh, here we go. Here's where I just took that slide over from the cellular presentation. So yes, anabolism takes ATP, uses it, and puts a molecule together. Catabolism breaks a molecule apart, and that releases ATP into your cell. Okay, so when you're doing anabolism, you're building proteins and you're building glycogen. When you're doing catabolism, you're breaking structures apart so you can get the ATP from it, and you're digesting foods. So digestion in the digestive system is a process of catabolism. And then using everything that came from the digestive system to build your own body is anabolism. Okay, so we're going to talk about those macronutrients now, just so you know. Why do we need to know this? I've actually been asked that. Why do we need to know this? It's because it's part of a general healthcare provider education. That's why you need to know it. If you already know this, don't worry about it. But for those of you who don't, what are carbohydrates? They are molecules that can be broken down into quick ATP production, and then they can be stored in the body as glycogen or turned into adipose tissue. This includes sugars, starches, fiber, which are non-digestible fiber. High glycemic foods can raise your blood sugar rapidly, as we all know. Eating chocolate cake and watermelon, they're delicious, but they will create a spike in insulin, which is created by our pancreas. More macronutrients would be lipids. These are our fats. So that salmon's there because it's fatty. So they're called triglycerides. That's mostly what they are. They provide dense, long-term energy, ATP that is. They're broken into fatty acids and glycerol. They're stored as adipose tissue when there's too much. And they are required for vitamin absorption and hormone production. We need fat. Fat is good as long as it's a healthy kind of fat and not a processed fat. Our proteins that we can get from our legumes and from our grains also, as well as eggs, and there's some lemon and lettuces in there, but don't worry about that. Mostly look at the eggs and the meat and the fish, and let's pretend that's tofu right there. Anyway, so they are, I didn't look at that image enough when I was like, wait a minute, why is the tomato and basil in there? Digested into amino acids. That's proteins are, when we eat the meat or we eat the soybeans or drink the milk, the protein is converted into an amino acid, which our body uses for tissue repair, for creating enzymes, for creating hormones, and for our immune molecules. Our whole body needs those amino acids for all kinds of stuff. So too many amino acids get converted into adipose tissue. So what have we got so far? Carbohydrates, fats or lipids, and proteins all can be stored as adipose or glucose. And then other nutrients, those would be our vitamins and minerals that we need as well. So it is important that we do know the difference between water-soluble and fat-soluble vitamins for the MBLEx. So water soluble vitamins would be the B vitamins and the vitamin C, which doesn't get stored. So water soluble vitamins don't get stored in our bodies. And then fat soluble vitamins can be stored, like vitamin A, vitamin D, vitamin E, and vitamin K. They can be stored in our fat, in our adipose tissue. And then let's include water as a nutrient. It makes up the majority of body fluids. It's mostly water. Our body's mostly water. You've heard this many times. Water is essential for digestion, absorbing our nutrients, for enzyme function, for temperature regulation. Nearly 7 liters of digestive secretions are produced daily in our digestive nutrients, vitamin and minerals. I didn't mention this. They're required as coenzymes for metabolic reactions. We just need them for our bodies to function properly. Okay, so that's everything that we needed to cover for this section for the digestive system. That wasn't so bad. Let's go through these questions in the style of the Massage and Bodywork licensing exam. First question. Mechanical digestion in the stomach is primarily accomplished through, let's look at this again. Mechanical digestion. Remember, mechanical is the churning part, right? In the stomach. Remember, we have the stomach. And remember, what makes the stomach do mechanical digestion? It's those smooth muscle tissues. So let's look at our possible answers. A, segmentation. Now remember, the small intestine does the segmentation, where it has different directions that it will churn from in order to mix the contents. So I don't think that's the correct answer. B, circular and longitudinal contractions. So those live not just in the stomach, but they also live throughout the entire gastrointestinal tract, except the mouth and the pharynx and the anus. Peristalsis occurs throughout the whole digestive tract. And then D, churning by 3 layers of smooth muscle. The stomach is the only structure in the gastrointestinal tract that has those 3 layers. And so I'm going to choose D for this answer. Explanation. The stomach has an additional oblique layer of muscle that allows powerful churning and mixing, making mechanical digestion highly effective. Segmentation occurs mainly in the small intestine, not the stomach. Peristalsis moves food forward rather than mixing it. Circular and longitudinal contractions alone cannot achieve the strong mixing unique to the stomach. Okay, next question. Which digestive organ is the primary site for chemical digestion and nutrient absorption? The primary site, I know what the primary site for nutrient absorption is. That's what I was talking about. But also for chemical digestion. Interesting. A, the stomach. That's where most of the churning happens to start breaking things down. B, the small intestine, I know, is where most of the nutrient absorption happens. C, large intestine, is where most of the water absorption happens. And then D, pancreas, is where we have some enzymes and some, the pancreatic juice, I think that's what they call it, for neutralizing the HCl coming out of the stomach. And then also insulin, digestive hormones come out of the pancreas as well, because it is an exocrine organ. So I'm going to go with B, small intestine, because that makes the most sense for digestion and nutrient absorption. Okay. Explanation. The small intestine performs approximately 90% of nutrient absorption thanks to villi and microvilli that dramatically increase the surface area. The stomach begins protein digestion but does not absorb most nutrients. The large intestine absorbs water and vitamins, but not macronutrients. The pancreas provides enzymes, but is not a site of absorption at all. Next question. Which structure prevents food from entering the nasal cavity during swallowing? Ooh, remember we were talking about that? About the food that could be pushed back up into the back of the nose? We don't want that to happen. Oh, that sucks when it does. Has that ever happened to you? It has happened to me. A, epiglottis. Epiglottis would be the flap at the base of the throat, which keeps the food from going down into the trachea. B, uvula and soft palate. Did I talk about the uvula? C, lingual tonsil. Tonsil is an immune or lymphatic structure. And then D, upper esophageal sphincter. The upper esophageal sphincter is right below the epiglottis around our throat. So as far as the nasal cavity goes, what makes the most sense to me is the uvula and soft palate. So let's find out what the uvula is. During swallowing, the soft palate and the uvula elevate to block the nasopharynx, preventing food from entering the nasal cavity. The epiglottis blocks the trachea, not the nose. Tonsils play an immune role, but do not direct food. The upper esophageal sphincter regulates entry into the esophagus, but not nasal protection. Real quick, I want to go back to that slide with the there we go, uvula. There it is. So, darn it, I pushed the wrong button. Here we go. The uvula, its pointing is, let's see, the palate would be that, and then the uvula is like the end of the soft palate. Okay, so now we know. I did say uvula in the slideshow, but I forgot. Where was I? There we go. Uvula and soft palate. Expand. Okay. So we already did that one. Last question. Which macronutrient must be broken down into amino acids for absorption? So which macronutrient, remember we had 3 macronutrients besides water, and it's the one that breaks down into amino acids. So we have A, lipids, that's the fat. B, proteins, that's the meat. C, carbohydrates, that's the sugars. And D, vitamins. Okay, that's right, we did have 4 besides water. I'm going to go with B, proteins. Explanation. Proteins are digested into amino acids so that they can be absorbed and used for building tissue, enzymes, hormones, and immune molecules. Carbohydrates are broken into monosaccharides like glucose. Lipids become fatty acids and glycerol. And vitamins are micronutrients and don't require digestion before absorption. That's what I got wrong. So vitamins are not a macronutrient. The macronutrients are those 3, carbohydrates, proteins, and lipids, and vitamins are micronutrients. Okay, we're getting it all figured out here. So thank you so much for watching today. Now we're done with the digestive system. We just have a couple more segments to go to finish the anatomy and physiology series. Make sure you're subscribed so you can be in the loop about future videos. And if you haven't liked this video already, please do so that other future massage therapists and bodyworkers can have access to this information so that they can pass the massage and bodywork licensing exam as well. And with that, I'm going to say toodaloo. See you in the next video.